Welcome to video 6.1 on stoichiometry. In this video, we're going to understand the purpose of stoichiometry. And we're also going to learn to use the mole ratio to convert between different chemicals within a chemical reaction. So get your pencil, get your notes, grab your mole map and your periodic table, and get ready for another exciting lesson. So as we get started, we have our key terms here, stoichiometry and mole ratio. Stoichiometry is this concept of how we can relate or find a relationship between reactants and products. When you think of stoichiometry, you can think about how you make a sandwich. And you can also think back to what we learned last unit in balancing a chemical equation. So here below, I have an equation on how to make a sandwich. In my house, we grew up a little poor, and so we were only allowed to take one piece of meat and one piece of cheese when we made a sandwich. And so in our equation here, you can see that it takes 2 pieces of bread, 1 piece of meat, and 1 piece of cheese to make a Lawrence sandwich. So now translate that into what we're doing in chemistry, and translate that into what you already know about chemical reactions. Here we can see that hydrogen and oxygen come together to make water. When we went back and balanced this to obey the law of conservation of mass, we see that we need 2 molecules of hydrogen gas with 1 molecule of the oxygen gas, and it would actually make 2 water molecules. In stoichiometry, we're going to use these coefficients and turn them into a conversion factor known as the mole ratio. So a mole ratio is simply the coefficients from a balanced chemical equation turned into fractions. So these coefficients from a balanced chemical equation can be used as a conversion factor to allow us to convert from 1 mole of a substance to another one. So I want to show you how to do a problem from start to finish using what we learned last unit and where we're going in with this unit. And so as we do it, pay attention and watch how I use our mole map, our solubility sheet, and our periodic table to accomplish this problem. Now again, I am showing you a little more review since you're just coming back from a break, but really this is it wrapping things together, and I'm going to show you the big picture for the kind of problems we're going to do in this lesson on stoichiometry. So as we read the problem, we see it says carbon dioxide reacts with lithium hydroxide to form lithium carbonate and water. How many moles of lithium hydroxide are required to react with 15 moles of carbon dioxide? So just like last unit, we need to convert the words into a formula equation. So I need to list out what is carbon dioxide. Then I need to show it reacts with lithium hydroxide. Lithium hydroxide, again, all this comes from your periodic table. Lithium hydroxide, -1 charge plus 1 charge, so they come together in a 1-to-1 relationship, and they are going to form lithium carbonate and water. Now we got to go back and make sure we have our equations or our chemical formulas written correctly. This is how you write water. Lithium carbonate, lithium has a +1 charge. Carbonate has a negative, where are you at, carbonate? 2 charge. And so through the cross method, I see I need 2 lithiums with every carbonate. Now, we learned we need to balance this. So as I go through here, I'm going to pick lithium. I have 2 lithium, so I'm going to put a 2 here. Then we'll just keep bouncing back and forth. Now I'm going to check my hydrogens. I have 2 hydrogens, 2 hydrogens. I have 1 oxygen plus 3 is 4 oxygens. 2 oxygens plus 2 is 4 oxygens, 1 carbon, 1 carbon, therefore it is balanced. Now, because we want to be thorough, we can go through here and we can label whether they are liquid, gas, solid, or aqueous. So carbon dioxide, we should know that's a gas because we breathe it out all the time. Lithium hydroxide, we use our sheet, we find our hydroxides, we expect it to be insoluble, we expect it to be a solid, unless it's one of the exceptions. So then I say it's a solid unless it's with an Ia element? Well, Ia is right here, Ia. So if it's one of these, it's going to be aqueous. And so we look, and since we have lithium hydroxide, lithium is in the 1A. As I read this, it says all will be solid unless it's bonded with lithium hydroxide. So here we can see this would be an aqueous. And then now I have carbonate. So again, I look at my carbonates. I expect carbonate to be a solid. Any compound has carbonate, I expect to be a solid, unless it's one of the exceptions. And yes, lithium is in the 1A group. And so therefore, it would still be aqueous. And then if I look at my water, we would assume that's going to be a liquid. So unless I tell you we're at some weird temperature, we're going to understand it's in a normal environment, so it's liquid. So this is kind of a review of what we've done so far. Now we get into stoichiometry. Stoichiometry, again, is just the relationship between the reactants and the products. And it can also be used to see the relationship between reactants or see the relationship between products, or again, the reactants and the products. So here's how you're going to want to set up these problems. So again, watch to the details, pay close attention. Let me show you how to do this, and then we'll do tons of practice in class. So the way I like to set up is once I get my chemical equation, I like to list things underneath each chemical that's given to me in the problem. So how many moles of lithium hydroxide? So I have lithium hydroxide. I'm going to put a question mark here and put moles. So how many moles of lithium hydroxide are required to react with 15 moles of carbon dioxide? So what we're going to do here is we're going to do a conversion problem. So when we get a conversion problem, we have to think about our mole map. And what we see here is that we are giving the units of moles, and we want to convert to another mole of a different element. And that's where we're going to do a conversion problem between this box and this box. So to do this, we're going to use what's called the mole ratio. And that just simply comes from the coefficients. Pause the video and you can write this down on your mole map. So all we're doing is we're going to do the 3 steps that we did. We're going to write down what we know. We know from the problem we have 15 moles of carbon dioxide. Here it's really important you do keep the name of the chemical here because now we're starting to transfer between chemicals. So again, 15 moles of carbon dioxide. I just got that from the problem. We're going to do step 2, which is follow your units, mole of CO2, mole of CO2. And then we're going to do step 3, get a conversion factor. So again, if I'm in moles of one thing, moles of one chemical, I can convert to liters or grams or particles of that chemical. Or now I can convert from moles of that chemical to moles of another chemical using what's called the mole ratio, which are simply the coefficients. So I can go from mole of CO2 to mole of lithium hydroxide. And so now I have to find that ratio. And according to my coefficients, 1 mole of carbon dioxide can produce 2 moles of lithium hydroxide. So again, the only thing new we are learning right now is that this coefficient comes from these values. Got it? Now, put that in my equation, and I can simply see 2 times 15 means I'm going to need 30 moles of, I need 30 moles of lithium hydroxide to react with 15 moles of carbon dioxide to make this reaction go. So again, it's just like the bread situation. You need 2 pieces of bread for every 1 piece of meat. Or in this situation, you need 2 compounds of lithium hydroxide for every 1 compound or 1 molecule of carbon dioxide. Now, this is the very basic. This is a very basic conversion we're going to do between a mole to mole. Let me go ahead and show you what else it would look like in this unit. We're not going to simply just convert from mole to mole, but instead I can give you grams of carbon dioxide, and you should be able now to also do a huge conversion problem to convert to grams of lithium hydroxide. So again, if instead of giving you 15 moles, and I said, hey, you have 660 grams of carbon dioxide, we are now going to be able to go from here to here, to here to here, and then here to here, and end up with grams of lithium carbonate. So again, you would just follow your units. Reminder, how do I get this conversion factor? I just add up the masses off the periodic table. I know carbon's 12.01. I know oxygen's 16 each. So that's 32 plus 12.1 is 44.01 grams, so 1 mole. Then again, I just converted from here to here. Now we're going to convert from here to here. Go follow my units again. CO2 to 2 moles of LiOH, which again is from right here. And then now I am in moles of LiOH, and we're going to convert back to grams. So I would follow my units again, and I say 1 mole of lithium hydroxide would be how many grams of lithium hydroxide. Look at my periodic table, 1.01, 16, plus 6.94. If I put that in my calculator, because I don't really have that number memorized yet, 1.01 plus 16 plus the 6.94, I see that this is 23.95 grams. And then again, if I did my math correctly, I'd come up with 719 grams of lithium hydroxide. So all we're doing in this lesson is learning this mole ratio, but then you're going to use what you've learned before and do a long problem like this, converting from grams of one thing to finally grams of another thing. Idea here, though, is our coefficients give us the mole ratio. Our coefficients give us the mole ratio, and it allows us to convert between moles of one thing, moles of another thing. So like I said, welcome back to Chemistry 1. In this video, we're just seeing stoichiometry is a relationship between reactants and products, or between two reactants, or between two products. And our mole ratio is just simply using the coefficients to make a conversion factor between those chemicals. Have a great day.